Hi everyone, this video refers to section 7.2 of our textbook, One Sample Proportion Tests. So we'll go through an example problem that takes you through the full process of how to do a hypothesis test that focuses on proportions. So we have a cereal company claims 55% of Americans start the day with cereal for breakfast. You want to test this claim, so you randomly sample 100 Americans and ask them what they eat for breakfast. 48 of them say cereal. Test the cereal company's claim at the 0.05, or in other words, 5% significance level. So the first thing that we want to do is state the random variable and the parameter in words. First, let's talk about the symbols. So for the random variable, we are going to use our sample proportion, which we use p hat in this case. And just to be clear, the p here is lowercase. Likewise, for the parameter, we just use a lowercase letter p. In order to describe both the random variable and the parameter in words, we need to refer back to the narrative. So for p hat, this is going to be the sample proportion, so call it what it is here, of 100. So we want to call out the sample size that we are explicitly working with here. And we should also note that they are randomly sampled. Americans. And we want to put in as much detail as we can, so we want to call out that they are eating cereal for breakfast. Once you have your description for your random variable down, you pretty much get to recycle the phrasing for your parameter. So for your parameter, we're really just going to say that this is the proportion of all. Because again, parameter is referring to the population of interest. So from here, we can basically just use the same wording or the same description that we had in the sample proportion. So all Americans who eat cereal for breakfast. So the next step is we are going to state the null hypothesis, which we denote as H sub O, the alternative hypothesis, H sub A, and the level of significance, where we use the Greek letter alpha. So for the null hypothesis, we are basically going to reference what we originally believed before we did any kind of data collection. So before we did anything, we are making this claim, or we are hearing this claim, that 55% of Americans are eating cereal for breakfast. So what we are saying here is H sub O is going to be P is equal to 55% or 0.055. Please note that when you are setting up your null hypothesis, you are always using an equal sign here. When we move over to the alternative, this is where you will use an inequality, either in the form of less than, greater than, or not equal to. You're going to use one of those three. That's the only part that changes when you're talking about an alternative hypothesis. So in this case, we would have H sub A. We are still going to be talking about the population parameter. I guess that's redundant, because the parameter always refers to the population. And we're still going to be working with that original proportion of 55%. What we are going to do is we'll use the results from our sample to indicate which of the inequalities we should use here. In this case, out of 100 Americans, we found that 48 of them eat cereal for breakfast. So this translates to 48% or 0.48. So in this case, because it's smaller, I'm going to choose to use an alternative hypothesis that claims that the new parameter is less than 55%. It's less than what was originally claimed. We'll go ahead and we'll leave it there and move over to our significance level. The significance level question is really just reading comprehension. What did the narrative tell you to use here? And in this instance, they told us to use a significance level of 5%, or in other words, 0.05 or 5/100ths. The next thing that we're going to do is state and check the assumptions for a hypothesis test. We have 3 items that we need to double check before we can proceed. Those are indicated in black here. So the first question that we ask ourselves is, was the sample a simple random sample? And we can automatically say yes here because it was stated in the narrative that the 100 Americans that we looked at, they were randomly sampled. The second thing that we want to look at is, are you only working with 2 categories? And again, we can say yes here. The 2 categories that we are working with would be those Americans who do eat cereal for breakfast, and the second group would be those Americans who do not eat cereal for breakfast. It can be that kind of quick and simple. So we can check that one off. Now we're going to check, is the sampling distribution of p hat approximately normal? And here we want to look at the number of successes, quote unquote successes. So in other words, we're defining a success as a person who does eat cereal for breakfast. Those are the people that we are most interested in. We also want to make sure that we have more than 10 failures. And failures, again, we don't necessarily have to throw a negative connotation on it. We're basically just saying someone is a failure in this case if they do not fit the detail that we're interested in. So in other words, anyone who does not eat cereal for breakfast. So in order to determine this, we have a quick little formula that we can use. So it's going to be the sample size, n, times the population proportion, or what we assume to be the population proportion. Remember, we did define what p was earlier when we were talking about the null hypothesis. We said that p was equal to 0.55. So this is the value that we're going to use here. So for our sample size, we know that we are working with 100 people. And with our population proportion, we are going to use 0.55. This ends up giving us 55, which we know is greater than or equal to 10. So this checks out. So we do have more than 10 successes. And then we also have to do this for failures. So it's not enough to just do the successes. We also have to do the calculation for failures. It's kind of a combo. You have to do both in order to actually move forward. So here again, our sample size is 100, and we're going to do 1 minus our population parameter. Again, sorry, I'm being redundant. So this will become 100 times 1 minus 0.55 is 0.45. 100 times 0.45 gives us 45. This is definitely greater than or equal to 10, so this checks out. The third point here, the population size, which we refer to as capital N, is greater than 20 times the sample size. We can kind of assume here, or you could Google the American population size. But in this case, if we did 20 times our sample of 100, that gives us 2,000. I'm pretty confident that there are more than 2,000 Americans. So this last one, it may not be necessary. You can kind of maybe go more off of assumptions, but you definitely want to check to make sure that you have at least 10 or more successes and 10 or more failures. For our next step, we want to find the sample statistic, the test statistic, and the p-value. Please note that all 3 of these items can be found using your calculator. I'm going to go ahead and take some time to at least show you the calculations for the sample statistic and the test statistic. The sample statistic is very quick. So our sample statistic, again, we denote this as p hat. This is going to be looking at, out of the random sample that you worked with, how many individuals said that they eat cereal for breakfast. And again, returning to that narrative, we found that 48 of them did. So this comes out to 48%, or if we work with the decimal form, 0.48. Your test statistic is going to be your z-score. And in order to find that, we would say z is going to be equal to p hat minus p, or your book might say p sub 0. Both of them are referring to the parameter. They're basically just 2 different notations to represent the same value. I'm going to include the p sub 0 in here just because it does, it is mentioned in your textbook, so I want to kind of be consistent for you there. And this is going to be all over the square root of p sub 0 times 1 minus p sub 0 all over your sample size n. Remember, your z-score tells you how many standard deviations above or below your population proportion your sample proportion is. This might be able to tell us whether we are working with an extreme value or not. So in this case, we know that our p-hat is going to be 0.48. We know that our population proportion is going to be 0.55. We're going to repeat that in the denominator here. So 0.55 times 1 minus 0.55. If you would prefer to write 0.45 in there already, so take care of the subtraction first, go ahead and do that. And then we'll divide that by 100. Going through the appropriate order of operations, we would simplify this all the way down to negative 1.407052941. So this is telling me that the value of my sample statistic is 1.4, roughly, standard deviations below our population proportion. So since it's not 2 standard deviations below, I can kind of already get an idea that it's not an extreme result. Let's move to finding the p-value next. So make sure that you have your calculator out. If you don't, please pause the video to grab it. So the first thing that we're going to do is we're going to get rid of that stray line and go to Stat. We're going to arrow over to Tests. From there, we are only working with one proportion here. So we are going to choose to work with option number 5, which is going to be 1 prop z-test. From here, you can either hit 5 on your keypad or you could hit enter. And here we are going to be asked to fill in some new information on a new window. So we have p sub 0, we have x, we have n, and then you're just going to see the word prop there. So for p sub 0, again, this is going to be our population proportion. X is going to be the number of successes we had from our specific data collection. So not from our check, but from the narrative where they had shared that we had 48 people tell us that they ate cereal for breakfast. N, as always, is going to represent your sample size. And your prop here, you're going to want to refer back to your alternative hypothesis. So here we are concerned with looking at a result that is less than our population proportion. After this, we'll go ahead and we'll do a calculation. And we'll get the following results. As you can see here, we do get the same z-score, or the same test statistic that we had when we had done this by hand. The p that you see here, this is your p-value. So this is why we kind of see p sub 0. So p sub 0 is usually referring to your population proportion. If you just see a p on your calculator, this is referring to the p-value. So this is the probability of getting 48% from your sample, assuming that the population proportion is actually 55%. Then we see that we do get our sample statistic in here as well, which again, we had found up here. And then they just call out your sample size again. So now we're ready to make a conclusion. So in order to make the conclusion, what we need here is we need our p-value, and we need our level of significance, or in other words, our alpha. So we're going to compare these two. We said that our p-value was 0.07970589959, and we said that our level of significance was 0.05. If it helps, I would convert some of this over to, or I would convert both values into percentages. So here, let's say that we have about a 7.97%, and then we have 5%. So what we can call out right away is that 7.97% is greater than 5%. When your p-value is bigger than your level of significance, we fail to reject the null hypothesis. Please note that I am saying we fail to reject the null hypothesis and not we're supporting the null hypothesis. Language is really important within statistics. So we aren't supporting it. We're basically just saying nothing better has come along or nothing has been able to come along to change my mind. So I'm failing to reject it. I'm going to hold on to it for now, but note that I'm not like touting it as like this is the correct answer. It's just nothing has come along to change my mind. So now that we have this information, we can go ahead and interpret our conclusion. So there are 3 things that you want to include when you are writing your conclusion. 1, you want to make sure that you include the significance level in your write-up. 2, you want to just provide the general conclusion. So you can refer back to the steps that we have above, and you want to call out that you fail to reject the null. The last thing that you want to do is bring in some context. So talk about the situation that you were investigating. So we should have something along these lines. So at the 5% significance level, we fail to reject the null. So basically your second sentence is going to be, what does this mean? In our situation, we would say there is not enough evidence to support the claim that less than 55% of Americans eat cereal for breakfast. In order to compose that second sentence, we can refer back to how we had defined the population proportion in our very first step. In other words, what we had said P was equal to, which we had said that was the population proportion of all Americans who eat cereal for breakfast. So we can use that description here again. And we're also referencing the alternative hypothesis when we had said P was less than 55%. So really quickly, just as an alternative, I know this video is very long, but maybe someone is saying or wondering, well, what happens if my p-value was less than 5%? So just for the heck of it, let's kind of do a hypothetical here. Say that instead of 7.97%, you had done your work and you had gotten a p-value of 4%. Well, this changes everything quite literally. So because 4% would be less than 5%, this means that we would reject the null hypothesis. And as a result, our interpretation of the conclusion would also change. So we would instead say at the 5% significance level, we reject the null. And then here we would say there is enough evidence to support the claim that less than 55% of Americans eat cereal for breakfast. This is because if we are rejecting the null, we automatically have to support the alternative. So I guess that would be another talking point as well. You are always going to either you're either sticking with the null hypothesis or you are going to support the alternative. There's never going to be a situation where you are going to dump both the null and the alternative, basically saying neither one works for me, I don't like either one. And there's also not going to be a situation where you can take both the null and the alternative and say, I like both of them, I want both. They are at odds with each other. So you are either always going to stay with your null hypothesis and dump the alternative, or you're dumping your null to support the alternative. So either way, when you are doing any kind of hypothesis test, you are siding either with the null, so staying with it, or you're siding with the alternative. I hope this was helpful. If you have any questions, please let me know.